My name is Jonathan Fair, Senior DevOps Engineer, part of the CloudOne team. And just wanted to go over general understanding of CaaS. I know you heard some of it in Mike's presentation just now, and why we created it and how our application teams are using it. So we have a lot of different offerings that Mike just mentioned, and he went over DevOps and IaaS, and I'll be going over CaaS here a little bit more in depth. So CaaS delivers a predefined template Helm chart and end-to-end CI/CD pipeline that includes security scans and approvals. This allows developers to spend more time improving their application instead of maintaining and troubleshooting the pipelines. So why did we build this? In the past, developers are responsible for developing their application. They're usually not familiar with Kubernetes and security and everything else that may be involved. So they would normally need to start with a CI/CD pipeline. They'd need to learn and work with Azure pipelines and several security integrations such as JFrog X-Ray, SonarQube, Prisma Cloud, Coverity, Docker, Helm. You get the point. The list is pretty long, everything they would need to learn. So what we did is we set out to automate this and provide it as a service. So I'll show you now how our application teams get started using CaaS with the day one automation. So we have our ServiceNow portal. This is for the application owners to manage their CloudOne services. Here they would onboard their application with their tier and cost center. So we do cost tracking for depending on what they order and what tier their application is. Then they order any host spaces. So these are basically namespaces based on the landscape, production stage, t-shirt size, and cluster region. So the t-shirt size is just limiting, sets the quotas and limits within the Kubernetes project, and along with for PVC sizes, number of PVCs, CPUs, memory. Once they order that, they can order any databases using our CloudOne DevOps or database as a service offerings. And finally, order the CaaS instances that they need. So if their application requires several images, they would order a CaaS pipeline for each image. Once the user clicks submit, ServiceNow will create the CIs in our CMDB and kick off the playbooks in Ansible Tower. Our playbooks will create Docker repositories, Active Directory groups for developers, leads, DBAs in operations to manage access and perform approvals. It then creates OpenShift projects with roles assigned to those Active Directory groups. An Azure DevOps project is created with repositories, service connections, variable groups, and pipelines. And finally, the workspace and host spaces are created. You can think of the workspace as more of a namespace where the developers can spin up instances and bring them down quickly, where the host space is our stage and production environments for more in-depth testing. Once everything is provisioned on day one, the day two automation begins. And this is the pipeline that we actually provide during the day one automation. The developers can begin deploying their application using this pipeline. Once the developers make any necessary changes to the Helm chart template that we provide, they can push their image to our JFrog Artifactory. This will automatically trigger their CI/CD pipeline. The pipeline will make sure the provided parameters and Helm chart is valid and make sure the image exists in Artifactory. It'll then perform both code and image security scans and provide the results to the developers. The pipeline will continue to the workspace, even if there are vulnerabilities. That way the developers can fix and test any of those vulnerabilities in their development workspace. If the developer is not satisfied or not happy with the deployment, or needs to make some more changes before going on to the next stage, the developer can halt the pipeline and start the process over after making the needed changes. If the developer is happy with the changes and approves it, the pipeline will remove the deployment from the workspace so the developer can begin working on the next feature. In the meantime, the pipeline will wait for the application leads to approve the deployment to the stage host space. Once approved, it will perform the deployment and allow the business to review the application changes in the stage environment. Once the business approves this, it will check the security scans performed earlier and see if there's any major vulnerabilities. If there were any, it will halt the pipeline and require the developer to resolve those. If there are no vulnerabilities, it will go to the operations queue to allow them to check the logs in Splunk, perform any load testing, synthetic transaction monitoring, whatever they decide to do. Once operations approves, it will deploy to production. This entire process can take 15 to 20 minutes, depending on how long it takes for the individual team members to go through the approvals. But generally end to end can be 15 to 20 minutes. So this is what the pipeline looks like in Azure DevOps. This is one example. And this example is with one stage host space and one production host space. The host spaces can be defined within their very easily. The user in their repo can then just pick which host spaces they want to deploy to. So if they have one application they want to deploy to 2-stage host spaces and a specific production host space, they can easily define that in YAML format. In this example, it has the workspace, 1-stage host space, and 1 production host space. Currently, it's deployed to the workspace and waiting for the developer to review and approve that. If the developer approves that, then it'll go on to the stage host space. So CaaS has proven to us in our application teams that automation can significantly reduce man hours spent on setup, day-to-day operations, and troubleshooting. It provides a reliable application while reducing our compute footprint. CaaS allows our developers to do what they do best, which is develop their application. It provides end-to-end or enterprise-level security to all applications without the need for monthly OS patching downtimes and routine manual security audits. So this is our DevSecOps service for imaging containers.